All right, guys, continuing on with our discussion of sequences. This is another way to express a sequence. It's called a recursive rule. And I'm going to be honest with you, it's not nearly as powerful as an explicit rule or a general rule because of two things. First, you have to be given at least one term of the sequence in order to use a recursive rule. And that's unlike the explicit rule where you don't need to know any terms. You can find any term you want. And again, the second shortcoming of a recursive rule is that you'll only be able to find the next term in the sequence. Given a term, you can find the next term, so to speak. It is used a lot. Okay, I probably won't quiz or test it as nearly as much as the explicit rule, but I want to make sure I cover it, make sure you know what a recursive rule is, how to use it. The toughest part is the notation. Now you already know that the nth term is denoted by a subscript n. To denote the previous term, it's just going to be the subscript of n minus 1. So if we're trying to find a certain term and we know the term preceding it, we can certainly find the next term if we know what the rule or the pattern is. Okay? Again, not nearly as powerful or as important as the explicit rule or the general rule, but it is worth covering. So just a couple of examples, maybe a couple homework questions on it. Maybe it appears on one question on a comprehension quiz or on a real quiz. So here's what it would look like. It would say the nth term is 3 times the preceding term plus 4. And that's how you have to read it. Don't read it with subscripts. The nth term is 3 times the preceding term, or the previous term, plus 4. Again, they have to give you some term in the sequence in order to have any chance of doing this. So in this particular example, they also throw in the tidbit that the first term is 5. Okay, so if somebody asked you to find the first 4 terms, they gave you the first one, so easy enough. You never should get full credit taken off on it, even on a recursive rule problem. So if I wanted to find the second term, it would be 3 times the first term plus 4, and exactly the third term would be 3 times the second term plus 4, and the fourth term would be 3 times the third term plus 4. Okay? So you can see in the recursive rule, you're always relating a term to the previous term. And again, instead of using n minus 1s, you can say, okay, the second term is something in regards to the first, third is something in relationship to the second, the fourth is obviously something to do with the third. Well, if the first term is 5, we can just say the second term is 3 times 5, 15, plus 4, 19. And then the third term will be 3 times that term, so 3 times that is 57, 57 plus 4 is 61. And if we kept going, 3 times 61 is 183 plus 4, 187. And then we keep going if we wanted to find more, but this just says, again, the first 4 terms. Again, you can see sort of the limitations of the recursive rule. It certainly is just relating yourself to the term in front of it. You need to have at least one term given to you in order to produce. Okay, not quite as good as the explicit rule. Here we got one where it says the nth term is negative 2 times the previous term minus 3, and they give us the third term. Ooh. All right, so we don't know the first term, we don't know the second term, but we know the third term is 4, and obviously in either of these directions we have to find the fourth term. Again, there's a lot of ways you could do this. Sometimes it's just pattern following, figuring it out. You know that the third term is 4, and to get to the fourth term, we would do negative 2 times the third term minus 3. And again, we know the third term is 4, so negative 2 times 4 is negative 8. And then negative 8 minus 3 is negative 11. So clearly, it looks like the terms are getting smaller. Okay? Obviously, when you multiply by negative, it's going to happen that way. Also, could be that it bounces back and forth between positive and negative. It just depends on the sequence. So how do we work backwards to find the second term or the first term? Well, Again, you can use some algebra. You can try to just do it by puzzle figuring, but you could say something like, all right, I want to find if the third term was -2 times the second term minus 3. Well, you could certainly solve that for the second term by saying, okay, let's move the 3 over, add 3 over, so the third term plus 3 is -2 times the second term. And then you could say, obviously, all right, divided by 2, so the third term plus 3 divided by -2 is equal to the second term. Okay, so third term was 4, so 4 plus 3 divided by -2 is -7/2. And you can check yourself to see if you have that right, because let's just try this. Let's multiply this by -2. Multiply that by -2, 2 to cancel negative, you get 7, 7 minus 3 is 4. Okay? And obviously we could use the same sort of math to try to figure out what the first term is. Okay? And again, this formula here kind of gives you already a ready-made solved way to do it. You could say that the second term plus 3 divided by -2 would be equal to the first term. Again, this gets a little ugly with the fractions because the second term is -7/2. So -7/2 plus 6/2 divided by -2 is going to equal the first term. So that's a -1/2 divided by -2. -1/2 divided by a -2. So that's just going to be 1, I believe. Actually, it should be -1. Let's try that again. Got -1/2 divided by a -2, so that's going to be multiplied by another -1/2 to equal the first term. So the first term is going to look like 1/4. Again, let's try that. 1/4 times a -2 is -1/2, and then -1/2 minus 3, so -6/2 does work. So obviously a little easier when they give you the first term of a recursive rule, because then you can just go straight forward and find the second, third, and fourth. A little tougher when they give you a term that's not the first term, because you have to backtrack to figure out the terms that preceded it. It's always easiest to find the terms that follow the term that was given. And again, that's another shortcoming of the recursive rule, but it is something you'll see in both this chapter and those of you going on to calculus. You'll see it in some sequence and series that you do there. Okay. So that's it for sequences. I know that was a quick lesson there, but we will then start our next lesson and we'll get into series and kind of finish off section 8.1. All right, thanks.